At the start of every lesson, it's important that you plug your USB into your robot. You'll be working with your files on the USB at all times, never saving them to the Raspberry Pi itself. It is your responsibility to make sure that every member of your group gets those files towards the end of the lesson. When you first open up your Raspberry Pi, you'll have to open the Thonny Python IDE. And that's this one down here. And basically this is a programming tool for programming Python. It's quite a nice one. It takes a while to open the first time, and I like to do a few things before I start. The first thing I'm going to do is I'm going to maximize it to full screen. The second thing I'm going to do is I'm going to go to Tools, Options, and make sure that line numbers are on. Okay, you can see that now I've got a line number there. That's always helpful. And the final thing I'm going to do is I'm going to save it to my USB, even though it's an empty file. And the one I'm going to do today is the first one, the LED activity. So basically going to go save. And I'm going to make sure it's onto my USB. So if I go to the main folder here, I can find my USB in Media, in Pi, and I should be able to see the name of my USB. My USB is called Store and Go. So I'm going to put Store and Go there. You see I've already got one Python file on there. Just ignore these things here. And I'm going to call mine LED Basics, which is the name of the first activity. So we're going to work with the for loop, and the for loop is a way of repeating code over and over again, but it's got a special counter in it as well, so we can actually count up or count down, as the case may be, when we're doing our code, and that's very useful to be able to do. At the moment I've got some base code in, and it's the base code you've seen before. If I run the current script, it will start it and the LED will turn on. There it goes. And if I press stop, it will turn off because it's got a keyboard interrupt in it which cleans it up and turns it off. So that's the base code that we're going to be using, and we're going to start by putting our loop in this section here. So we're just going to leave the LED on, and we're going to use the for loop, and the for loop starts with the word for, and you can see that that turns purple. And you need to use a variable. You can use any variable you want. I'm going to use the word counter, and you can see that it'll actually count, and it's going to go from a range in range, and the range will be from 0 to 10 to begin with. And we're going to put one of these colons here. It's going to automatically indent, and everything in the loop will actually work. So all I'm going to do now is print the counter, and we haven't seen print before, but print will display information from the counter in the shell. So let's actually see what happens here when we hit save and we hit play, and you should see it's sitting there counting, and it's counting really fast. So I'm going to hit stop, and you can see that it goes 0, 1, 2, 3, and if we scroll back a bit, it goes all the way to 9, and then it goes back to 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and back to 0. So it starts at 0, and it finishes at the one before 10, and it increments counter by 1 each time. That's a bit fast, so let's slow it down. We're going to put a sleep in so we can see it happen, and we're going to put in a sleep in at 0.5 just to see this happen. So we're going to save that and hit run counter, and you'll see that the script is running now. You see down here in the shell 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and it goes back again, and it loops around, and when we hit stop, it obviously stops working and cleans that up. So basically we have this ability to make our computer count up, and if we were to go the other way, we have to put in a special one. So we're going to go 10 to 0, and we have to put in -1 here to tell it to go backwards. So let's see what happens there. So I'm going to hit stop, I'm going to hit play, and we can see 10, 9, 8. So you can see it starts at 10 and it never gets to 0. So if you wanted to start from 10 and go to 0, you probably have to go -1 here. And hit stop here, save it, play. And you'll see that it goes from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. So that puts that in there. So that's very useful for us to be able to do or create a loop in terms of being able to count up or count down. I'm just going to change this back around so that it was at the start. We're going to go from 0 to 11 just to get it to go from 0 to 10. Hit save, hit play to test that, make sure it's all good. And there we go, counting up all the way to 10 this time. In order to get this to work with our LED, there's a slight problem, and the problem, I'll put it as a comment here, is we need our brightness to be between 0 and 1. And let's just say we want 100 levels of brightness. So let's just go with this. We're going to change this to 101, so it's going to count up to 101. Let's just change this down pretty quick to 0.01 as well, so we'll see it happen quickly. I'm going to hit save, I'm going to hit run, and we'll see that it's going to fly up the screen here, and it's going to count all the way up to 100. Make sure it does go to 100. So there's 50s, there's 60s, there's 70s, there's 80s, there's 90s, there's 100 and back to 0. I just saw that fly through, so I press stop now. And we can basically now figure out that we need a brightness between 0 and 1. So let's actually create a thing called brightness, and we'll set it equal to the counter divided by 100. And then let's just print out counter and then comma brightness and see what we get. So if we're going to hit save now, and we're going to hit play, you'll see that we get two values over here, provided I haven't done it right. Yep. So you can see it's counting up to the right number there, but it's also counting up here to a number that's all between 0 and 1. So if we want to basically just have our LED to fade in from 0 to fully bright, we can basically copy or get rid of this line here and instead use this variable brightness as our value for our LED. So we can go LED underscore FL dot value, as we did in the previous tutorial, is going to be equal to the brightness. That's fairly straightforward. Now, printing out stuff takes time for the computer to do. It slows stuff down, so we're going to comment this out. It's good to have that there just in case you need to be able to use that for diagnostic reasons. Say, for example, you're getting an error and you want to see what your values are, but it will slow you down. So we're going to hit or comment that out. I'm going to save that now, and I'm going to run the current script, and I should see my LED start off fairly dim and slowly get brighter, and eventually it will go out again and do the same thing. You'll notice that the LEDs generally do most of their dimming in the first probably 50%. That's because of the way I've set these up. So basically we need to be aware that most of the dimming occurs in the first 50%. In order to complete your activity, you need to show the teacher the code and the LED demo as per the tutorial. To get a better result, you need to show the code and robot of all of the lights working, fading both in and out, and you need to ensure that you have cleaned up all of your PWM LEDs. To get full marks, you need to create your own useful custom PWM LED function to transition the front LEDs to turn on and off by transitioning with a fade. So when you turn them on, they fade in, and when you turn them off, they fade out. And you need to make sure that you clean up all of your PWM LEDs with a single function.